Okay, Algebra 2 skills number 44B, log graphs. Let's take a look at a log graph and kind of what it looks like and the basic features. First of all, graph definition. Graph is simply a picture of all the solutions. So if you have an equation generally that has x and y in it, all the ordered pairs that when placed into x and y respectively that makes a true statement is going to be graphed with a solid point. And it's the connecting of all those points that makes the graph. So for a log graph, this is the basic appearance. Notice it has a vertical asymptote right here. It's not going to cross that line, and it begins to flatten out, but it's still going up on this side. So much like the exponential graphs, it's flat on one side, and it's flat actually over here, and then steep on the other. So the features of a log graph, we've already noticed it has a vertical asymptote, and it actually occurs with the horizontal shift. So everything's in reverse of the exponential graphs. If you're familiar with those, with an exponential graph, the horizontal asymptote occurs with the vertical shift, but here the vertical asymptote occurs with the horizontal shifts. Also, we want to focus on the x-intercept, and anytime you ever find an x-intercept, it's always the same process. You just put a 0 in for y and solve. And again, we've already mentioned it's steep on one side and flat on the other. So here's one example, clearly a log function here, and we've got x and y, so let's graph it and tell the domain range. So the vertical asymptote is x equals 3. Again, if you know anything about graph shifts, you know that if you subtract on the inside, that's a horizontal move that actually goes right. So you change that sign, so x equals 3 is your vertical asymptote. Remember, the vertical asymptote is a line, so you do need the x equals. It would not be correct to say the vertical asymptote is at 3. It is at x equals 3. X-intercept, you're going to, again, take this right here, put a 0 in the y position, and now you need to know how to solve log equations. So let's solve this. There's an understood 10. 10 to the 0 power equals x minus 3. 10 to the 0 power is 1, so x is 4. So vertical asymptote occurs at x equals 3, and it crosses the x-axis at 4. So let's observe that. There you go. X equals 3, the green dashed line, which is actually not part of the graph, but it helps draw it. That is your vertical asymptote, and there's your x-intercept there at 4. You can see it clearly crosses at 4. Again, it's steep on one side and flat on the other. Okay, the domain here, again, this goes back to a lot of previous information. If you understand domain, are all the x's covered by a graph. It goes left until you hit 3, and it goes right forever. So it's understood that you have a concept of graph shifts and domain range before watching this video. Range is going to be all real numbers here because you go down forever and you go up forever. It is flattening a bit, but it will continue to go up forever. So that's going to be the range of every single log graph. Will be all real numbers. The domain, however, will depend on where the vertical asymptote is. Two more examples. It's a natural log, but it's much the same. Again, the vertical asymptote occurs with the horizontal shift. It does not occur. This 2 has no bearing whatsoever on where the vertical asymptote is. For the x-intercept, change y to 0, so that y becomes 0, and now we're just solving. Add 2 to both sides. Now there's an e here. Again, it's understood that you know how to solve log equations. E squared is x plus 1, and x is going to end up being 6.39. I did 2 steps at 1 there. I subtracted 1 from both sides, and if you type in e squared minus 1, that's approximately 6.39. So looking at the graph, there's your x-intercept that we talked about, -1. Excuse me, the vertical asymptote at -1. X equals -1. And 6.39, that looks right there. And notice also that it's a little lower, and that's because of this -2. So that -2 does have an influence. It doesn't actually show up in the numbers, you know, for what we actually calculate, but it has been dropped, and the x-intercept's location kind of has that go down a couple spots there. So that's still a vertical shift down too. Now the domain does not care about the vertical shift, it only cares about the horizontal shift, so the domain number will always match the vertical asymptote number. So -1 to infinity, and the range, again, is all real numbers. Third example. Okay, this one has, again, if you know about graph shifts, this is going to be a upside down flip, that negative there. So let's see what happens here. Vertical asymptote is x equals 0 because there is no horizontal shift. There's no parenthesis there. That 4 does not affect. If that was in parentheses, now it would be at x equals -4, but it's not. So x equals 0 is your vertical asymptote. X-intercept, change y to 0, and just solve it. Subtract 4 from both sides. Divide both sides by -1, and then 2 to the 4th power, which is 16, will be your x-intercept. Now when we graph this, Notice it's upside down. That's no surprise. The vertical asymptote's up here at x equals 0, and it begins to flatten the other way. Notice we didn't have room to actually show the x-intercept, so you just, if you don't have enough room, you just kind of draw it with that understanding that it's going to cross at 16. We just don't have enough room to show it. Or you could change the scale if you wanted to and have it actually cross. The domain here again has nothing to do with the shift, so it's going to be 0 to infinity. That's all about the horizontal shift. So the vertical asymptote, which is the horizontal shift, occurs at 0. And the range again, despite the fact that it's upside down, that doesn't matter. It's still all real numbers. So log graphs.